All right, welcome back, everyone. Today we're going to talk about factoring special products. In this lesson, you're going to learn how to recognize a perfect square trinomial, how to factor a perfect square trinomial, and then how to factor the difference of two squares. So when we talk about special cases of polynomials, there are some special cases that can be factored. And recognizing these will help with factoring. It'll make factoring a lot easier. So the first type of special case is what's known as a perfect square, or a perfect square trinomial. A perfect square trinomial is just one that's a product of two linear factors that are the same. So something like a squared plus 2ab plus b squared, that'd be equal to a plus b times a plus b. Those two factors are the same. So we could rewrite that as just a plus b squared. The same thing would go for the one below that. So to recognize if something's a perfect square trinomial, you first want to check that the first and last terms are perfect squares. And then you want to check the middle term by multiplication. You want to make sure that if the first term is a squared and the last term is b squared, the term in the middle should be 2 times a times b. And so that's how we're going to check and see if something is a perfect square trinomial. So we want to determine if 9x squared minus 12xy plus 4y squared is a perfect square trinomial. Well, what we have is 9x squared minus 12xy plus 4y squared. Our first term is 9x squared. That's 3x squared. The last term is 4y squared. And that's the same thing as 2y squared. So both of those things are perfect squares. Now we just want to check that the term in the middle is 2 times a times b, or 2 times two times 3x times 2y. And what you get is 12xy. And that's our middle term. And so this thing is a perfect square trinomial. So now that you should be able to recognize perfect square trinomials, we want to talk about how you would actually factor them. And so factoring a perfect square trinomial can be done in one of two ways. If you recognize it's a perfect square, then just use the formula. If not, we're going to use the method that we used for factoring previously. So we're going to do this problem, x squared plus 12x plus 36, and we'll just do it both ways so you can see the difference between the two. Well, x squared is just x squared. 36 is just 6 squared. And the middle term should be 2 times x times 6, which is 12x. And so we have a perfect square trinomial. And so to factor this perfect square trinomial, if you look back at the previous formulas, a squared plus 2ab plus b squared is equal to a plus b squared. And so what we have, a is just x, b is just 6, and so we get x plus 6 squared. Now this works just fine. If you can use the formula, by all means, use it. It's faster. But we can still use the same method we've been using to factor these things. Right? So assuming the number in front is 1, we're going to take the first number and the last number and multiply them together. So 1 times 36 is 36. Make ourselves a box, 1x and 1x. We now need two numbers that multiply to give you 36 and add to give you 12. Well, 36 is 6 times 6. And 6 plus 6 is 12. And so now we write our two factors, x plus 6 and x plus 6. But we could just rewrite that as x plus 6 squared. So both methods will work, and whichever you're most comfortable with is the one you should use. For the remainder of these examples, I'm going to show you using the old method from the previous section. But if you can recognize these problems and use the formula, it'll be a lot faster. So here we want to factor 25x squared plus 20xy plus 4y squared. So we'll take the first number and the last number, multiply them together. 25 times 4 is 100. We make ourselves a box down here, 25x and 25x. And this time we have a y, so we want to account for that in the bottom. And now we need two numbers that are going to multiply to give you 100 and add to give you 20. Well, 10 times 10 is 100, and 10 plus 10 is 20. And so now, we've just got to reduce each side like a fraction. 25 is divisible by 5, and so is 10, and we'll get the same thing in both of them. And so you get 5x plus 2y times 5x plus 2y, or just 5x plus 2y squared. Another special case is known as the difference of squares. So something a squared minus b squared is going to be factored to a plus b and a minus b. To recognize the difference of squares, simply check that both terms are perfect squares. And you want to make sure that there's a minus sign in between them. And so we can use the formula to factor, or we can use the method before with just one slight little change. So here we have z squared minus 4. So for this one, we'll use the formula. Z squared minus 4. That's z squared minus 2 squared. So they're both perfect squares. And so we can rewrite that as z plus 2 and z minus 2. And that would be our factored form. Now, we can still use the method from the previous section in section 4.2. But we've got to make one little change here. We need a middle term, and there's not one here. So we can rewrite this thing as 4x squared plus 0x minus 1. Right? We're just going to put a 0 in there as a placeholder. And now you can factor this just like we factored everything else. Take the first number and the last number and multiply them together. 4 times negative 1 is negative 4. We can then make a box. We'll write the coefficient both times and split the variable. You now need two numbers that multiply to give you negative 4 and add to give you 0. Well, that's negative 2 and 2. So remember, we can reduce each side like a fraction. 2 goes into 4 2 times, and it goes into 2 once. Same for the second one. And so you get 2x minus 1 and 2x plus 1. The same thing you would have gotten if you used the formula. So let's try this again. Here we have y to the 4th minus 16. Now, in a problem like this, where it's not something squared minus a number, but instead something to the 4th power minus a number, it's going to be beneficial to use the formula. So that's what we're going to do. We got y to the 4th minus 16. Well, that's the same thing as y squared squared minus 4 squared. And so what we get is y squared plus 4. and y squared minus 4. Now the first term, y squared plus 4, is what's known as a sum of squares. And a sum of squares cannot be factored. You just have to leave that term the way it is. But y squared minus 4, that's still a difference of squares. And so we could take this a little further and say that y squared minus 4 is going to be y plus 2 and y minus 2. So we essentially use the difference of squares formula twice. Once to break the fourth power down into y squareds, and then once to break down the y squared minus 4. So remember that you can always remove the greatest common factor first before you attempt to factor. Here we have 4x cubed minus 49x. Well, they both have an x in common. And what we're left with is 4x squared minus 49. So again, we can just rewrite this. 4x squared plus 0x minus 49. Take the first number and the last number and multiply them together. 4 times negative 49 is going to give you negative 196. And so now we need two numbers that multiply to give you negative 196 and add to give you 0. So negative 14 and 14. Now we can reduce each side like a fraction. 4 divided by 2 is 2. 14 divided by 2 is 7. And what we're left with is 2x minus 7 and 2x plus 7. And then just remember you have to bring down the greatest common factor, and so it'll have an x in front. So at the end of this lesson, you should be able to recognize perfect square trinomials. You should be able to factor perfect square trinomials. And you should be able to factor a difference of squares.